Alright, so in the last video we have seen the exact definitions of trigonometric ratios, right? So we have discussed the basic definitions which you learnt in 10th class, and also we discussed what is the exact definition of sine theta, cos theta and tan theta, right? Just for recap, sine theta is nothing but the y coordinate of the point divided by the radius, distance of the point from the origin. Okay, so if theta is in first quadrant, that is acute angle 0 to 90 degree, then you will have sin theta as positive value. So let's discuss all these things practically using some examples now. Okay, so here we have y-axis, x-axis. All right, let's say there is some straight line like this, making some angle. Let's take 30 degree. Okay, so 30 degree. Now we want to find what is sine 30 degree. Okay, so we are not going to discuss the values and all. We are just going to see what is the sign, means whether it is positive or negative. Okay, sine 30 degree means you take any point on this line, any point you take, some random point, x comma y. What is sine 30 degree? Definition: the y coordinate by this distance r, right? So for sine 30 degree, both y and radius anyway it's always positive. The y coordinate is positive, correct? So that means sine 30 degree should be positive. So whenever some angle is given, always remember you need to first think of whether it is in in which quadrant the angle lies, so that you can tell whether it is positive or negative. Then we can think about its value. Alright, so 30 degree is in which quadrant? First quadrant. 45 degree, first quadrant. 60 degree, first quadrant. 70 degree, first quadrant, up to so on, up to what is the limit? The limit is 90 degree, correct? 90 degree, if you draw a line, you will get a line coinciding with y-axis, correct? So you will get line like this, okay, and this is 90 degree. So now if theta is in first quadrant means 0 degree less than or equal to theta less than or equal to 90 degree. What can you say about sine theta? Sine theta is going to be positive. What can you say about cos theta? Cos theta will also be positive, correct? Because x coordinate is also positive. Cos theta is x coordinate by distance of the point from the origin. Okay, so cos theta is also going to be positive. Now let's go to second quadrant. Second quadrant is this one. Okay, they are named like this. Okay, now second quadrant, let's take some angles. Let's take some angle like this. Let's say this is some 120 degree. Okay, now in second quadrant, if you take any point on this line, what can you say about the y coordinate? Sine theta, sine 120 is y coordinate by radius. Y coordinate is positive, right? It is positive. So sine 120 is going to be positive, correct? What can you say about cos 120? Cos 120 is x coordinate by radius, and x coordinate is going to be negative. This is negative x-axis, correct? So cos 120 is going to be negative. So keep this basic things in mind. Any angle in second quadrant you take, sine theta is going to be positive, cos of it is going to be negative. What about 150? Okay, so this is, let's say, 150 degree. For 150 degree also, sine is going to be positive, cos is going to be negative. Now till where it goes? It will go till 180 degree, that is second quadrant. So in first quadrant all the trigonometric ratios will be positive. In second quadrant sine will be positive and its reciprocal cosecant theta will be positive. Cos will be negative. Cos will be negative. If cos is negative, secant also negative. And if cos is negative and sine is positive, sine by cos, that is tan. Tan will also be negative. And if tan is negative, its reciprocal cot is also negative. So all these fellows will be negative, but sine and cosecant will be positive. So in second quadrant all silver. Silver means S for sine, and of course its reciprocal cosecant. Okay, so please keep this in mind. Whenever you say an obtuse angle or an angle in second quadrant, immediately what should come to your mind? Sine and its reciprocal is positive. All others are negative. Okay, now let's go to third quadrant. Now in third quadrant you will have angles like, let's start with 180 plus 30, that is 210 degree. Okay, so when you have angles more than 180 and less than, this is how much? This angle will be 180 plus 90, no? This entire angle 180 plus 90, that is 270. So more than 180 and less than 270, that is third quadrant. What you are going to get? Both x coordinate and y coordinate both will be negative. So sine theta will be negative, cos theta will be negative. So if sine theta is negative, its reciprocal will also be negative. Cos theta negative, secant theta will be negative. So all these four people are negative. What about sine theta by cos theta? That is negative by negative. So tan theta is going to be positive. That means tan 210 is positive, and its reciprocal cot 210, that is also positive. So all silver T for tan and its reciprocal, they are going to be positive. So whenever you see an angle between 180 and 270 degree, you should immediately come to your mind that tan and its reciprocal cot are positive, all others are negative. Okay, you should not think, it should not take so much time to strike in mind. You should become very much familiar with these things. Whenever some angle is given, immediately you should identify which quadrant it is and immediately identify which trigonometric ratios are going to be positive and which are going to be negative. So next, last quadrant, that is fourth quadrant. Here you have angles more than 270 and less than 360. Of course, if it is measured in anti-clockwise direction. Okay, so if they are measured anti-clockwise direction, here you will have some line like this, a random point on it, x comma y. Y coordinate will be negative, therefore sine is negative, cosecant is also negative. Next, what about x coordinate? X coordinate is going to be positive, so cos theta is positive and secant theta is positive. So sine is negative, cosecant is negative. Sine by cos, that will also be negative, that is tan, and its reciprocal also will be negative. Alright, so in this fourth quadrant, cos theta and secant theta. So what can you say about cos 300? Cos 300 is positive. What can you say about tan 300? Tan 300 is going to be negative. Okay, so once we have known, once we become very familiar with these angles and all, then we can think about how to find those values. So how do we find those values actually? So for that there is a very simple method. Let's go one by one. See, first quadrant angles, all of you are quite familiar, right? first quadrant angles. All right, so let's discuss first quadrant angles. These angles which are already there in 10th class syllabus: sine 0 degree 0, sine 30 degree how much, 1 by 2, cos sine 45 degree 1 by root 2, and sine 60 degree root 3 by 2, sine 90 degree, it's 1. So I'm not writing for cos, tan, secant, cosecant and cot, okay, that you already know. I'm just revising just for sine. So these are first quadrant angles. Now let's go to second quadrant angles, which we are not so much familiar. Second quadrant angles, we may not be able to find out on our own for all the angles, but whichever is linked to the standard angles we can find. Okay, so for example, sine 120, sine 120 degree is there. How do you find it? We can write sine 120 as, try to always write these numbers in terms of the standard angles. Okay, 0, 30, 45, 60 and 90. So if you see 120, you can write as 90 degree plus 30 degree, right? Now whenever 90 degree is coming, sine should change to cos. Okay, and whatever is remaining, that should come here, and before this you should get plus or minus. Now whether it is plus or minus, that depends upon your previous concept. What is that? You have to decide in your mind whether the final value is going to be positive or negative. So 120 degrees in second quadrant, and we know that in second quadrant sine is positive, so therefore we write plus cos 30. And what is plus cos 30? Plus cos 30 is root 3 by 2. Alright, so similarly let's take some another example. Let's take tan 150 degree. So you can write tan 150 as tan of 90 degree plus 60 degree, right? So whenever 90 degree comes, sine should become cos, cos should become sine, tan should become cot, and cot should become tan. Be careful here. Sine, it should become cos, not its reciprocal. But whereas in the case of tan, tan will become its reciprocal. Okay, so don't confuse. Sine, it will not become its reciprocal, it will become cos. It's not cosecant, it's cos. Whereas tan, it will become its reciprocal, that is cot. The reason for this I am not explaining in this video. You can check out your CBSE textbook for the proof of all these formulas. But right now we will just discuss how to find out these values. So cot 60, that is equal to how much? Cot 60 degree is 1 by root 3. Right, so let's take another example. Sine 180 degree. Sine 180 is how much? Actually, okay, let's do by this method first, and then we will discuss some other easy method. Sine of 90 plus 90 is how much? It will be cos 90, that will be 0. Or in the diagram you can see 180 degrees this line, and for this point, any point you take on this line, y coordinate is going to be 0. Sin theta is y coordinate by radius, so sin 180 is y coordinate is 0, 0 divided by radius, that will be 0. Okay, so these are second quadrant angles. Now let's go to third quadrant angles. Let's take some third quadrant angle, sine of 210 degree. Okay, so how will we write it? you can write it as 180 plus 30 degree. Now whenever a multiple of 180 is there, in the sense, see, this is multiple of 90, this is also multiple of 90, and how do you know the difference? Very simple, this is the odd multiple of 90 and this is even multiple of 90. So whenever odd multiple of 90 is there, the sine should become cos, tan should become cot, and similarly secant should become cosecant, like that. But whenever even multiples of 90 is there, like 180, 360, 540, 720, like that, those higher angles we'll discuss later. Like even multiples of 90 are there, then sine should remain as it is, sine. No change should happen. Okay. Now, but sine 210 we already know, it is in third quadrant, so it should be positive or negative? It should be negative. So it's minus sine 30 degree. Whatever is remaining here, that will come. That is minus 1 by 2. Now let's discuss some other examples. Sine 225. Sine of 180 plus 45. That is, sine will remain as sine, but it is third quadrant, so negative. Sine 45. That is minus 1 by root 2. Let's take some other example. Cot 240. Cot 240 degree is how much? Cot of 180 plus 60 degree. Now if you see 180, so cot will remain cot, but it is in third quadrant. Third quadrant, all silver, T for tan and cot, both should be positive. So it is plus cot 60 degree, that is 1 by root 3. So cot 240 is 1 by root 3. So these are examples of third quadrant angles. Now let's take fourth quadrant angles. So fourth quadrant angles means 270 degrees to 360 degree. Alright, so let's take sine of 300 degree. Sine of 300 degree, how we can write? Sine of 270 degree plus 30 degree, right? Now 270 is 90 into 3. It's an odd multiple of 90. That means sine should become cos, and this will come here. But sine of a fourth quadrant angle should be negative. So minus cos 30 degree, that is minus root 3 by 2. Because in the fourth quadrant, sine is negative. Only cos is positive. Cos and secant, all others are negative. Let's see what is tan of 315 degree. You can write this as tan of 270 plus 45 degree. Now 270 is the odd multiple of 90 degrees, so tan will become cot. This will come here, but it is fourth quadrant and tan is negative, so it is minus cot 45, which is minus 1. So let's take another example, last example. Cos of 330 degree. Cos of 330 degree, you can write it as cos of 270 degree plus 60 degree. Again, 270 is the odd multiple of 90 degrees, so cos will become sine, and this will come here. But here you will not get minus, because for fourth quadrant angles, cos is positive. All silver, T cups, no? Cups, C for cos and secant, it's going to be positive. Sine 60, that is root 3 by 2. Alright, so we have discussed how to find sine, cos, tan and their reciprocals for any angle given in all these four quadrants. Any angle means those which are linked to the standard angles 0 degree, 30 degree, 45, 60 and 90 degree. Okay, so you can try to become familiar with these angles. Any question asked in this regard, like find, let's say for example, find the value of sine 120 degree into cos 240 degree plus sine 225 degree into tan 330 degree. Any question where each and every angle is reducible to the standard angles, you should be immediately able to find it out. Let's solve this example and we will stop this lecture. Sine 120 is how much? Sine of 90 plus 30. Sine of 90 plus 30 means sine will change to cos, but it is positive, so cos 30, right? Similarly, cos 240 is how much? Cos of 180 plus 60, and it is third angle, so minus will come because cos is negative in third angle, and since 180 is there, cos will remain cos and it will become minus cos 60 degree. Similarly, this is third quadrant angle, so it will be negative, and it is 180 plus 45. 180 means sine will remain as it is, sine 45 into now tan 330 degree is fourth quadrant angle, so tan will be negative, and 270 plus 60 degree. 270 means tan will change to cot, so you'll get cot 60 degree. So if you substitute the values, what you'll get? Cos 30 is root 3 by 2 into minus cos 60 is 1 by 2. This is minus 1 by root 2 into minus 1 by root 3. So overall you will get minus root 3 by 4 plus 1 by root 6. This is the answer. Alright. Okay. So we'll stop the lecture here.